Assalamu alaikum wa rahmatullahi wa barakatuhu. I'm Sarifat Ali, and last time we have discussed motion 1.2, physics, kinematics 1, and we have discussed what is kinematics. Just to describe motion and characteristic of motion. This is kinematics without knowing the cause of motion. Okay, I have explained this thing. And what we have done last time? We have discussed on point, distance, displacement, speed and velocity. Now we'll continue further topics related to motion. Okay, so about distance, change in position in any direction. About displacement, change in position in some specific direction. Okay, speed, the change in position in a unit time in any direction. Velocity, change in position in a unit time, some specific direction. Okay, now we consider motion of a vehicle. We start journey, okay, from rest. It means there is a change in speed from rest to certain speed. Okay, due to different obstacle or speed breakers, there is a need to decelerate the vehicle, and on a smooth path there is a need to accelerate the vehicle. And if we are not facing anything else, then there must be a speed with a constant rate or constant speed, constant velocity, so different terms. But before it, there is a need to accelerate the vehicle, to decelerate the vehicle, so there must be a change in speed, there must be a change in velocity. The only difference between speed and velocity is direction. So if we use the word speed rather than velocity, so meaning to say we are not considering that time direction. Okay, now I am starting with a word acceleration. Okay. Okay, acceleration. As it is a vector quantity, so we should use the word velocity, right? But sometimes someone uses speed. Never mind, we can consider if we are talking about magnitude of acceleration. Okay, now listen. Sometimes it happens, but the right word is velocity. Okay, now listen. The change in velocity in a unit time. So, rate of change in velocity. Rate of change meaning to say in comparison of time with the rate of time. So it means the change in velocity in a unit time is called acceleration. Okay, I'm writing over here. A change in velocity in a unit time. A change in velocity in a unit time. So how much time required in which there is a change in velocity? Let's suppose the speed of a vehicle is 30 meters per second, and after 20 seconds we accelerate the car, and now the speed will become 50 meters per second. How much time required to change from 20 to 50 or 30 to 50? So when a difference in velocity is divided by the time taken or the interval of time, this is called acceleration. So it is the rate of change of velocity. So a change in velocity in a unit time is called acceleration. So we can write down acceleration is equal to change in velocity in an interval of time, like this. Change in velocity in interval of time. Okay, now the change in velocity meaning to say there or more than one velocity? Yes. An initial velocity. Suppose u, a final velocity after the change. Suppose v. So if we are increasing the velocity, so the difference must be v minus u. Final velocity minus initial velocity. If we are going to decrease the velocity, then there must be u minus v. So the increasing velocity is greater than the final velocity. Okay, now listen. Acceleration, we are talking about positive acceleration. So one can write down like this: v minus u upon time interval or time taken t. You can use, rather than del t, just write down t. It is the time taken. It is the time interval. So v minus u upon t. This is an acceleration. And if this v greater than u, if the v final velocity, it is the final velocity, right? So if final velocity v greater than initial velocity, then the acceleration would be positive acceleration. Then it is positive acceleration, where v is the final velocity and u is the initial velocity. V is the final velocity, u is the initial velocity, and the change in velocities in a unit time is called acceleration, and we have a positive value. This is positive acceleration. Simply we pronounce acceleration. So a positive change in velocity in a unit time is called acceleration. So if it is important that we have to define acceleration in comparison of negative acceleration. So a positive change in velocity in a unit time is called acceleration. This is called acceleration. And okay, about the unit. Okay, now the unit of velocity, meter per second. Okay, what is the unit of time? Second. So when we write over here about the SI unit, so SI unit of acceleration, SI unit of acceleration is, listen, in numerator change in velocity, meaning to say the dimension is the velocity, meter per second. When it is divided by once again by second, so this will be equal to what? Meter per second in a unit time per second. So this will be equal to meter per second square, ms power minus 2. This is meter per second square. So SI unit of acceleration, meter per second square. Now it is the double time rate of change in position. You know now, we have started from what is the point, and the change in position is speed in any direction. Change in position in some specific direction is velocity, and again there is a change in velocity. Rate of change in velocity is called acceleration. So it is the double time rate of change in position. This is called an acceleration. Okay, now it is acceleration. Simply a positive change or simply a change in velocity in a unit time called acceleration. Mathematically, we can write down change in velocity upon time interval or time taken. This can be resolved into v minus u. When you accelerate a vehicle, there must be a change in speed or velocity. So there must be initial and final. We consider v is the final velocity. Before acceleration, u after acceleration, v is the final velocity after acceleration, and before acceleration, u is the initial velocity. So the change between them, change in velocity. Okay, we are talking about the positive change. This is acceleration or positive acceleration. Now listen, if we are going to slow down the vehicle as there is a speed breaker or some obstacle or there is a signal, so we have to stop. So we have to reduce the speed initially, okay, till the vehicle will stop. Okay, Now, if we are going to slow down the vehicle, we decelerate the vehicle. So decelerate meaning to say the change is negative. This time the change is negative. Okay, so it means the direction of acceleration is the direction of velocity. No doubt. The direction of acceleration, it is a vector quantity. So the direction of acceleration is the direction of velocity. But when we decelerate the vehicle, the direction will be opposite. So the direction of acceleration is opposite to the motion. Right now, the direction of acceleration is the direction of motion. But when we slow down, the direction would be opposite to the motion. So listen, if we consider a negative acceleration, the word we use are deceleration, negative acceleration, retardation. These three words are used for negative acceleration. Okay, now listen what I'm writing over here. Negative acceleration or deceleration or retardation. Okay, negative acceleration or deceleration or retardation. Okay, now a negative change in velocity, a negative change in velocity in a unit time. Negative change, what does it mean? Okay, the initial velocity is greater than final velocity. A negative change in velocity. Okay, now I'm writing over here. A negative change in velocity. A negative change in velocity in a unit time or per unit time. In a unit time is called negative acceleration or deceleration or retardation. Okay, it means a deceleration or retardation or negative acceleration. This would be equal to what? It will be equal to deceleration is equal to negative change in velocity upon time interval t. Okay, it means write down v minus u divide by t, or one can write down when this negative sign applied over here. Now what happened? Okay, now negative v, positive u. So you can change the place as well, like this, u minus v upon t. Listen, this is a minus b. If we are going to replace their position, b minus a, you should take a common, take minus as a common. Okay, now if we have a upon b to power n, and we are going to write down b upon a, so you should take negative n. Same thing. If you replace their position, a power will become negative. If you replace their position, a sign will become negative. Same thing. So when this minus sign apply over here, minus plus minus v minus minus plus u. So we should write down u minus v upon t. So what does it mean? The initial velocity greater than final velocity. So write down over here, in case of negative acceleration, in case of negative acceleration, in case of deceleration, right? So u greater than v, u greater than v. There is a condition for deceleration. The initial velocity must be greater than final velocity, right? So u greater than v, we should write it over here. Okay, now the initial velocity greater than final velocity. Okay, now listen, what is the effect of negative acceleration? Now deceleration, negative change. The direction of deceleration as the direction of velocity, but the negative sign opposite the direction of velocity. So deceleration meaning to say same magnitude but opposite to the motion, as we are going to stop. So deceleration act opposite to the motion, or negative velocity opposite to the positive velocity, right? So deceleration meaning to say a negative change in velocity in a unit time, same as a unit. About the magnitude, meter per second square. It is the double time rate of change in position in a specific direction. Okay, one can say. Okay, so a negative change in velocity is in a unit time. This is negative acceleration or deceleration or retardation. Okay, it is clear. A formula for both acceleration and deceleration we have written over here. SI unit, meter per second square. It's okay. Now listen, we have discussed, we have defined distance, displacement on the basis of position, and then speed and velocity. And velocity lead to an acceleration, positive and negative. But these words are used in different sense. How in different senses? For example, speed is increasing or decreasing, or no change in speed. Velocity is increasing or decreasing, no change in velocity. So we have discussed motion, yes, but there are different qualities, different characteristics. Let's suppose, yeah, speed is increasing. Oh, so this is variable speed. Speed is decreasing. Oh, also variable speed. Okay, now speed is constant, uniform, no change in speed. Okay, so we have to consider speed as a whole journey. So there are three different words we have to utilize over here in O level physics and IGCSE. Okay, what are these words? Listen, we have to discuss these three words related to characteristic of motion. What? Number one, uniform. Number two, variable. Number three, average. Okay, uniform meaning to say constant. Constant meaning to say equal change in equal interval of time. Yeah, of course. Equal change in equal time duration. If there are equal changes in equal interval of time, okay, but the change in position or change in velocity, we will talk. Okay, now listen, just uniform meaning to say constant, no change, meaning to say equal changes, no change, meaning to say the changes occurs equally for equal interval of time. Okay, now I will explain it. Variable meaning to say non-uniform, variable non-uniform. It is non-uniform. What does it mean? It means no equal change in equal interval of time, or one can write down unequal changes occur in equal interval of time. Unequal. Okay, the word unequal changes. Unequal changes, but in equal time. Unequal changes in equal time. So it is non-uniform. It is variable. Okay, the word variable comes from vary. VARY. Vary change. Variety. There are different varieties. So many different things. Right? So VARI. Variable, non-uniform, not constant, unequal changes occur if so the term physical quantity showing variable behavior. Okay, now average. Whenever we consider average, meaning to say average as a whole throughout the session as a whole for the whole time of interval. So just write down as a whole over here. First, I define these three words. I explain what is the meaning of these three words. Okay, right. Now listen. We have to define uniform speed. This is uniform speed. What is the speed? Change in position in any direction. in an interval of time. Okay, so the change in position in given time in any direction, it is the speed. Or one can write down now, listen, again and again. Now we have a clear concept. What does change in position, any direction, distance. Now we can use the words speed, distance covered in a unit time. This is speed. Okay, so uniform means equal distances, distances covered in equal interval of time. Equal distances covered in equal interval of time. Equal distance is covered in equal intervals of time. This is uniform speed. Uniform speed, equal change in position in equal time duration. This is uniform speed. Okay, this is uniform speed, then variable speed. Variable speed, what does it mean? Non-uniform, okay. Unequal changes. So we should write down over what? Unequal distance is covered. Unequal distance is covered in equal interval time. Do not write down in unequal interval of time. Maybe possible these unequal have the same ratio with unequal interval of time. So you must place either over here unequal or over here. One can write down equal distance is covered in unequal interval of time. This is the definition of variable speed. But I use the word, I replace it unequal. So write down equal over here. Unequal distance is covered in intervals of time. Is it clear? Right? Equal distance is covered in equal interval, but over here unequal distance is covered. Unequal distance is covered in equal interval of time. And you can say equal distance is covered in unequal interval of time. Okay, give the same meaning. It will describe variable speed. It will describe variable speed. Okay, now listen. The third one is average. Third one is average speed. Okay, what does it mean? What is average speed as a whole? Okay, total distance covered, total interval of time. Simply, total distance covered in total interval of time. So whenever we divide the total distance covered in a journey by the total interval of time, although in between the journey we stay some time, or slow down, or increase the speed, become speedy. Sometimes there are stony path, inclined plane, speed breaker, not a smooth path. So we changes the speed again and again. Okay, but the distance covered throughout the journey when divided by total time duration, it means we are going to find out average speed and average estimation, right? So average speed, total distance covered in total interval of time, or just write down in total time. Okay, it's okay. Total distance covered in total time. Okay, this is average speed. Okay, now listen. Once you remember these words in different terms, physical terms, we can explain different terms on the basis of these three numbers. No doubt. Okay, whenever you are given a uniform data, so meaning to say equal changes, it means, right? So variable or thing that has an ability to change, this is variable. Okay, now listen again. Uniform speed, equal distance is covered in equal interval of time. Okay, variable speed, unequal distance is covered in unequal interval of time. It's okay. Average speed, total distance covered in total interval of time. And the formula for this one, total distance upon total time. The formula is total distance upon total time. You must write down yourself. Okay, you have to write down yourself. Average speed. What is the formula for speed? Speed equal to distance covered or change in position. Divide by time. Just increase the word. Total distance upon total time. Listen, I'm writing over here once. Listen. Whenever we talking about average speed, this will be equal to total distance divided by total time. And the average in mathematics, now we study about tendency, right? We study about it now. Central tendency of data. There are three different terms: mean, median, mode. Mean, median, mode. All these three show averages. So mean is an average, median, mode for different types of data. Is it clear? Okay, now average speed equal to total distance upon total time. Once write down this formula. Okay, now listen. I'm going to replace these words. Clear? Right? And also replace distance, distance over here as well, and distance as well over here. Okay, now listen what I'm doing. Uniform velocity equal displacements, equal displacement covered in equal interval of time. This is uniform velocity. Variable velocity unequal displacement covered in equal interval of time. Okay, average velocity, total displacement covered in total interval of time. So just if you know about uniform variable average, you can define velocity as well. The definition of velocity will involve displacement as it happen in a specific direction or vector quantity in the same way, right? So it means if there is a term involved in an exam, what? Define uniform speed. Yeah, speed, what is the definition of speed? Distance covered or equal distance is covered in equal interval of time. We have done all these things. Okay, now uniform velocity, variable velocity, average velocity. Okay, now after it, now about acceleration. Okay, about acceleration. If I replace these two words from uniform acceleration, if I'm going to write over here uniform acceleration, what would be the definition? Equal change in velocity in equal interval of time. Just replace, as we know that acceleration, change in velocity. Okay, we have done, right, just before. Okay, so what we have done, change in velocity in a unit time. So equal change in velocity in equal interval of time. Equal change in velocity in equal interval of time. This is uniform acceleration. Okay, variable acceleration, variable acceleration. Okay, unequal, this is unequal change in velocity in equal interval of time. This is variable acceleration. Variable acceleration, unequal change in velocity in equal interval of time. So it means we should not work hard for every and each terms. We should work on these three words. That we will be able to define uniform speed, uniform velocity, uniform acceleration, variable speed, variable velocity, variable acceleration, average speed, average velocity, right? We'll be able to define all these three terms. The main things, what does this mean, right? What does it mean? Uniform, equal, in equal interval of time. Okay, so uniform acceleration and variable acceleration. Now listen, there are some other explanation of the term uniform, variable, and average, right? But graphical presentation, in graphical presentation, and we will interpretation. There is interpretation, right? We will interpret what? Speed time graph, distance time graph, right? So it means in the third lecture, Kinematics 3, I will explain this thing, but before ending of this lecture, there is another term. Okay, what is it? Gravitational acceleration. This is gravitational acceleration. Okay, gravitational acceleration, what does it mean? Listen, sometime we just release an object from a certain height, right? We do not apply any type of force in downward direction, we just release. So there is a motion of an object downward direction. It's okay. When an object is thrown in our direction, it will move back. It comes back after some time. So it means in our gravitational system, there is free fall motion. So it means the motion in our gravitational system is free fall motion, and acceleration related to free fall motion is called gravitational acceleration. So what is the definition of acceleration? An acceleration related to free fall motion or an acceleration under the action of gravity is called gravitational acceleration, right? We are talking about characteristic of motion. If we will talk about cause of motion, I will discuss gravitational strength, I will discuss weight of an object, right? But now I'm just I do not discuss gravitational strength, but gravitational acceleration. So as we have discussed acceleration, so gravitational acceleration. Okay, now listen. Acceleration, acceleration under the action of gravity, acceleration under the action of gravity, acceleration under the action of gravity, or acceleration due to free fall motion, or acceleration in free fall motion is called under the action of gravity is called gravitational acceleration, right? During free fall motion. Okay, now gravitational acceleration is represented by g. It is represented by small g. It is represented by small g, and near to the surface of earth or at sea level, it is a constant value. It is a constant value near to the surface of earth or at sea level. Okay, now listen. Gravitational acceleration. Okay, what is the formula for acceleration? v minus u upon p. Same formula we use for gravitational acceleration, v minus u upon p. Same formula, same as a unit in meter per second square. It is in meter per second square. It is in meter per second square. So this is gravitational acceleration, same as an acceleration. But there is a need to draw a picture like this. Listen, it is a ground level or sea level. An object is moving in upward direction like this, and after some time it will move back in our direction. The object slows down or becomes speedy when a stone is thrown in upward direction. If it increase the speed, it never come back. But if it slows down after a specific height, it will move back. So it means when an object is moving upward direction, just one time we throw it, right? There is no interaction of forces. When an object is moving upward direction, due to gravity, it slows down. Slows down meaning to say the final speed is smaller than initial speed. So there is negative g. In upward direction, there is negative g. Okay. When it moves down, positive g. As speed increases. And one thing remember, the initial speed over here must be equal to final speed over here. These two are equal to each other. Listen. At this point, at what speed it is moving in what direction, it must hit the ground with the same speed. The object will hit the ground with the speed whatever injected initially, right? But listen, over here there is final speed. This will be equal to, for this journey, initial speed, and at this point the object will return. It will return. It must stop for microsecond. It must stop over here. The speed at this stage will become 0. This is the turning point. So at turning point, the speed will become 0 meter per second. So the final speed in upward motion or the initial speed in downward motion, both will become equal to 0. These two will be equal to 0. Okay, but the initial speed over here must be greater than this one. The final speed over here must be greater than this initial speed, right? Upward direction we consider the value of g or negative sign. Downward direction we consider value of g or positive sign. Why? As v greater than u. Over here, as u greater than v. Initial speed greater than final speed. This is the reason. So the upward direction consider negative, and the value of g near to the surface of earth, 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 the value of g is 9.8 meter per second square or 10 meter per second square. So if it is not given, take a value of g 10 meter per second square, 10. Or if it is given 9.8, you must place this one. But if it is not given, see the title page of your copy. There must be a g, value of g 9.8 or 10. Whatever given, you must use it. Alright? It must be given either on the title page or in the question. Right? So value of g 9.8 meter per second square or 10 meter per second square. Clear? So this is gravitational acceleration. Gravitational acceleration under the action of gravity is called gravitational acceleration, or one can say acceleration during free fall motion is called gravitational acceleration or acceleration due to gravity. Acceleration due to gravity. Okay, now listen, the last term before interpretation, before graphical presentation, before distance time graph, speed time graph, for under the action of gravity or simple vehicle, whatever we use on horizontal space, right? Horizontal surface. Okay. Now listen. Before it, there is a final term, that is terminal velocity. We know about the velocity. Velocity meaning to say displacement covered in unit time. The displacement covered in unit time is called velocity. Okay, what is terminal velocity? Okay, let's say during free fall motion. During free fall motion, what happened? An object is moving down, and as we have discussed, initial greater than final, final greater than initial, or initial greater than final. Okay, we have discussed. But there is a probability, there is a chance that during motion over here, there is no change in speed. There is a possibility, na, that an object is falling over a constant speed. How? Okay, a parachutist. A parachutist move down with a constant speed. Yes, parachutist move down with a constant speed. No change in speed. Right? So the term related to it, na, okay, write down terminal velocity. Okay, in the simplest word, uniform speed. Uniform speed under the action of gravity. Uniform speed during free fall motion, right? Or uniform speed in gravitational field. So just write down a uniform speed, a uniform speed under the action of gravity if there is a possibility. If there is a possibility, right? It is not compulsory that each and every object will move down with uniform speed. But if the speed of falling object is uniform, if it is possible, then a uniform speed under the action of gravity is called terminal velocity. Is called terminal velocity. Okay, a uniform speed under the action of gravity is called terminal velocity. Okay, why we use the word speed? Okay, now listen. One object is moving up or moving down. We are talking about two-dimensional motion. So there is no change in direction. If there is no wind blowing, we do not consider the blowing of wind, right? So if we neglect all other factors, there is no wind blowing, there is no friction of air, object is move up and down. So during upward motion or during downward motion, if the object is moving with a constant, with a uniform speed, this is called terminal velocity. And listen, after open the parachute, there is a case of terminal velocity. But there is a possibility, before open the parachute, there is a case of terminal velocity. Right? In both the conditions, it is not compulsory that a parachutist have terminal velocities. No, if parachute is not open, then there is a case of terminal velocity as well. Okay, we will discuss in a graph. There are two stages of terminal velocity: before open the parachute and after open the parachute. Right? But listen, a uniform speed under the action of gravity is called terminal velocity, or a uniform speed of during free fall motion. Uniform speed during free fall motion is called terminal velocity. Okay, now listen, all the terms we have completed. This is kinematics 2, right? Now listen, you must watch it. After watching kinematics 1, last time I advise you, I request you, I have requested you. What if you like the videos, please subscribe, like it. Okay, if you like it, then please like, or it is a request, subscribe, right? These terms, whatever I have discussed related to O-level physics, IGCSE, right? Related to physics. Okay. So please my channel, subscribe my channel, like it, comments, tell me what you need, what problem you need I should solve, right? What topics I should explain and share within your friends, within your friend circle, right? Within your social circle. Okay? So please subscribe my channel and share it to others, right? Inshallah, we'll meet next time with Kinematics 3. Allah Hafiz.